Good morning, afternoon, or evening, wherever you happen to be when you're watching this. My name is Mike Wackel. I'm a Senior Program Manager with the SQL Server organization, and I'm here to talk about using the power of extended events for tracing and troubleshooting in SQL Server 2012. Extended events is our new tracing technology in the database engine, and it's worth talking a little bit about what it is. This is a pervasive diagnostic system in 2012 that offers the advantages of scalability, performance, cross-process tracing, and integration with event tracing for Windows. You're going to see this technology take over as the primary diagnostic tracing tool for SQL Server, replacing SQL Server Trace and SQL Profiler. The key things I want you to take away from this talk is that extended events is going to enable you to quickly find the cause of problems in your server. It's going to allow you to get very detailed information, types of things that you haven't been able to see before with our tracing systems, and that we've significantly improved the usability of extended events in SQL Server 2012. Just a little roadmap for this talk. We're going to start off talking about Always On and how extended events is integrated into the troubleshooting experience in Always On. Then we're going to talk a little bit about how we can use correlation between processes to help troubleshoot logon failures. And then finally, we're going to go into how we get deep insight into the query execution process and use that to quickly dig into the cause of a problem with the query execution. So let's jump right into Always On. I'm sure you all know that Always On is our new technology for doing clustering and making highly available disaster recovery applications. And we've done a significant amount of work to make the diagnostic experience for Always On be really seamless end to end. One of the big issues with Always On is that you have a whole bunch of nodes in your cluster, and that means that the troubleshooting situation can be far more complex than just troubleshooting a single server. You could have a problem on your primary, on your secondaries. You can have problems in the clustering DLL. All of this stuff is actually instrumented with extended events now. What's really nice about Always On is the way we have diagnostics at many levels. You can look at your health state across the system using a dashboard. You can see the whole thing. You can start drilling into what's going on specific nodes. And then extended events comes into play where you want to drill into the details of what's happening with a specific problem. And then we'll even show you a little bit about how extended events can help you with the accountability once you find that problem to determine how that actually happened. So let's jump right into the demo. So you can see here that I have already set up an availability group. In fact, I've set up a couple availability groups. And we can just take a quick look here so that you can see I'm not lying. I have a couple availability groups for AdventureWorks and one that includes Northwind and Pubs. They're all there set up and ready to go. And you can see here that I have the dashboard up, and it shows me that everything is healthy and looking happy. So since this is about troubleshooting and how we can find a problem specifically, I'm not going to tell you what problem I'm going to cause. You can see that I just have a command script here that's going to go off and cause a problem. So I'll just run that. And what's going on here is that something has happened on our Always On cluster. Someone went off and did something. You don't know what it is because you're just a DBA sitting in your office waiting for something to happen. And in this case, if we go ahead and refresh our availability group, we can see, something's gone wrong here. We've got some red icons, some warning icons going in the cluster, and we need to figure out what's going to happen. So let's look a little bit at what we can see here. First off, I can just click here right in the dashboard and it'll pull up information about what's possibly wrong. It says, the availability group's not ready for automatic failure. Some availability replicas are disconnected. Now that's actually interesting to me because, obviously the reason they're not ready for failure is because something's not ready, is disconnected. One of the cool things here in the dashboard is once I select any of these possible issues, I can just click this More Information button, and that's going to pop up the Internet Explorer window and take me directly to a page on MSDN that tells me what some of the possible causes for that known issue is. And if I just scroll down here, okay, well, that tells me that something's disconnected. That doesn't really tell me all that much. We'll get rid of that. And we'll say, well, maybe what I want to do is go into this cluster. So I'm going to dig in there and see, oh, well, there's something wrong with this secondary here. Maybe I can find out more information there. So I'm going to do the same thing. Okay, that's disconnected. We'll click there through to MSDN. Oh, okay, this is getting more interesting here. Possible causes is that it's not connected. Could be because the port might be in conflict, the encryption type is mismatched, the connection endpoint has been deleted. All right, so it seems like maybe something is wrong with my endpoint. So let's drill into that a little bit. Let's pop open Object Explorer again. You can see I already have my secondary connected to here. So I'm going to go in and look at my endpoints. This is a database mirroring endpoint. Okay, well, it's there, so that's okay. But maybe there's something wrong with it. So just as a quick check, what I'm going to do is I'm just going to script it out to see what's happening with that particular endpoint. And this is just a simple way for me to go in and see what the definition of that endpoint is by scripting out what a create would look like. Now what's important here is I just noticed that the encryption is set for the algorithm RC4, and that's not what I originally set up. I originally set this up to be a different encryption method, and that seems like that might be the problem. So I can finally confirm this just by going back into my dashboard here and saying view always on health events. And this is where I can go in and I can actually see that I've collected a whole bunch of information about DDL that's been executed, reports that are happening, and I'm just going to scroll down and see this whole list of errors. And I'm going to pop this open and see that my error actually says that the database mirroring login attempt failed, and the error was connection handshake failed, there is no compatible encryption algorithm. So you can see using extended events I get this error that tells me exactly what's happening, and so I can say, somebody messed with the encryption algorithm of my endpoint. Now what I want to do here is I would actually like to fix that, and so I'm lucky enough I happen to have a little thing to fix this problem. I'm going to pop that in there, make sure I'm connected to the correct server, which I am, and I'm going to go ahead and run that. That completed successfully. You can see all I did is alter the endpoint and change the encryption algorithm. And if I go back to my dashboard, and it's going to refresh. It takes a few moments for things to flash back through. So we'll just refresh this a few times. Sometimes it takes longer than others. Or not. Let's look at this one more time. Maybe it didn't take. No, that took, so it's just taking my dashboard longer to refresh than I want it to. And there we go, finally. After things have worked its way through the system, you can see that my cluster is healthy again, everybody is in sync and ready to do failover. And I've just really been able to detect what's wrong very quickly, drill right into the extended events trace log that they've hooked up in extended events through the always on dashboard, and find out what's happening and figure out what to do to fix it. And we can see how that happens just really quickly if I drive under the management node, the extended events node, the session nodes, and you can see there's that always on health session, and that's a session that we build for you and turn on by default as soon as you enable always on a server. Now I did say that there was also a way that extended events helps out with accountability. So I had this problem that my endpoint got messed up somehow, and I might like to figure out how that happened. Well, another place that you see at least the same framework that we built extended events on is in SQL Audit. And I just happen to have had an audit running on my secondary here that I call audit changes. And that audit was set up to watch what was happening on the server so that I could go look what happened if anything changed that was bad. And you can see that, oh, I had a couple alter endpoints happen here. And one of them was me, obviously. But another one was probably the change. And what I can see is that I had this change here at about 450 when I ran this, where some idiot went and changed my endpoint. So I'm going to have to go and find this person and let them know that they need to not be able to change the endpoint, or maybe I should take some permissions away from them because they went and made a change. Now, I think it's important to mention that this is not really just a made-up demo that I came up with here to show some fancy icons changing from green to red and back to green. This idea of an endpoint changing the encryption format is something that we've seen in the real world. In fact, here at Microsoft, we had this initially when we were doing some testing with some of our internal IT shops. They had a problem where they had set up Always On and it didn't work immediately. And this was not just with 3 databases and 2 servers like I have. This was with hundreds of servers, and they had misconfigured just one server. And it was actually one of those things where, a phone call came in and it was a high priority. Oh my God, the world is coming to an end. And, we started mobilizing, but really within about 15 minutes, by the time we were ready to go and say, hey, what's going on? Let's troubleshoot this. We got an email back that said, oh, never mind. We were able to use the extended event log and find that the problem was the encryption, and we fixed it already. So, this is a real world demo that allows us to see how a real part of our system was able to use these tools to find the real problems very quickly. So that's Always On. Next, let's go into how we can use correlation to troubleshoot systems. So something new we have introduced in the time frame of SQL Server 2012 is this ability to correlate between different system tracing. Now, why is this important? The issue here is you've seen this type of diagram before. We don't just have a server or an application. We have things working together in the world now. And problems can occur at several different places. So you can have problems on your client. Your application code can have problems in it. The driver code can have problems in it. There can even be problems in the internet that's connecting the two pieces. And then on the server side, the server can have its own problems. There can be query plan problems, blocking, disk or network problems, different kinds of issues that can impact the server. Now, luckily, people have created systems that help you troubleshoot those problems. On the client, you have application logs and protocol traces for your diagnostics. On the server, we obviously have server traces. That's what we're talking about today. But we can see our DBAs down there. They're a little bit confused. These are all separate logs. They're on different systems. They're on different computers. And we're not sure how do we get information out of all of them together. That's a very complex process of pushing the stuff together and finding out, what means what, how did one thing cause another thing. And that's really been a problem for years. And the question is, how do we solve that problem? Well, starting in SQL 2012, we have something called a connection ID and an activity ID. And this is really the glue that we can use to start joining these two systems together. Now, it merits talking about these correlation IDs a little bit. The connection ID that we talked about, this is a single GUID that we're going to be able to generate on the client. And this is part of the code that's built into our protocols layer. So OLTP, the OLADB, ODBC, the stuff that goes through our TDS layer has this connection ID. And we generate it right there on the client, and we send it up to the server at pre-login. And this connection ID is going to be bound to the lifetime of a physical connection on the server. Now, the activity ID can be used for a little bit different type of correlation. This is a tuple of a GUID and a sequence number, so it actually identifies a thread, and then within that thread, the sequence of activities the thread that takes. Again, this is something that can be generated on the client and sent as part of the pre-login package when we're doing batch and RPC requests, and we can use it to track the transfers between threads and maintain the ordering of the operations. Now, both the connection ID and the activity ID are new things that we've added to the TDS protocol, so you do require a TDS update. And that's something that we're going to be shipping around the time frame of Visual Studio 11 and .NET 4.5. So first I want to talk about the login process a little bit and just go through the steps of what goes on here and how these IDs come into play. The first thing we see is we open that socket and pipe which is just the basic connection between the client and the server machine, so there's nothing interesting for us to trace there. The next thing that happens during login is that the connection ID is assigned at the client, so we generate this GUID at the client side. Next, the client goes through what we call pre-login, and this is where the connection ID and the activity ID, if it's being used, is sent up to the server. And then after that, from the client point of view, we send the login package, and this is where all the authentication information is sent to the server. And then finally, on the server side, we take in all that information, we assign threads for processing the login and the authentication credentials, and we enter the request into the database. So how do we use these steps and these correlation IDs to troubleshoot connection failures? So there's really nothing that we track during the open socket and pipe. This is just the basic connection. If this fails, you got bigger problems than tracking what's wrong in your client or your server. Next, we assign the connection ID, which generally is just not something that can fail. It's just we generate a GUID in the code on the client, and then we send that in the pre-login package. So this is really where we get the first interesting thing to see. Since we generate that connection ID, we're going to log it when we send pre-login in the client trace, so we'll log that there in the client side. And then when the server gets the pre-login event, we'll actually log that information on the server. So you can imagine that if you're having a problem with your login, you can go look at the client trace and the server trace. And if you see that connection ID in the client trace but not at the server trace, you know something has likely gone wrong in your network because we didn't even get that pre-login packet at the server. So the next thing happens on the client is it collects all that information about the login and it sends it up to the server, and so it logs information on the client trace that the login was sent. So again, if you see the login sent from the client but you don't see the login received at the server, you know that there's something going wrong in that sending. And then finally, when we get the login on the server and we assign all of the threads to process it, we can capture a series of very complex events that look in great detail at what goes on in that login, about how we use crypto and how we pass authentication, and we can actually look at there. And if we have login failures where we do see these connection IDs and activity IDs on the server, we know that we got the login information, but if login isn't successful, we can go and troubleshoot exactly where in the process of login the failure happened. So we're going to go and see this in action. First thing I want to do is just demonstrate a login failure. I have a little application that is going to go log into my server, and we're just going to run it here because it actually takes a few moments to run. And you can see the first thing that happens is I get a couple successful logins, but I'm running still. What happens in this particular application is it actually spins up a number of threads, and it goes and logs into the server and tries to make a connection and run a small query, and then returns information about the success or failure of my connection. And you can see here those first two I got, well, yeah, those were successful, but then I got a bunch of failures with this. Timeout expired, the timeout period elapsed, and I got disconnected. So something has gone wrong in my connection. And you can see here that the connection ID is something that's built right into that connection to the server, and it's something that in my application I can mine directly out of the result from the server login and print out. So how can we use this to troubleshoot something interesting on the server? Like right now I know that, well, I have a connection ID, that's cool, and I know I was timeout, but I need to correlate that with the server. Well, not surprisingly, the way we do that is using extended events. So we're going to pop in here to the extended event node under management right in Management Studio. This is our new UI. We've added this to SQL Server 2012 to make extended events a far more usable system. So you're going to see a lot of stuff in the extended event UI that's very similar to SQL Profiler. As I said, we need to start up a session that runs and collects information about our login. So I'm going to go to New Session and load up that new Create UI. And there's several pages here, and I'm not going to show everything, but I'm going to go through the parts of it. The first thing I want to do is give my session a name. And one of the things that we're doing is we're continuing this idea of templates in our UI so that you can drop down the template list and you'll see I have a whole series of templates that we've created that help you troubleshoot common tasks like counting query locks or looking at your batch or query detail execution. But in this case, I want to use one of the sessions that I've predefined myself. So you can create your own sessions and save them as a template. And I created this login session template. And this collects a bunch of information that's going to be useful to me in terms of troubleshooting this problem with login that we have, because I want some very detailed information. Just to look at a few other pieces of this UI and how it helps you create sessions quickly. You can see by selecting the session, I've already have my events selected, but it's worth taking a look at our event library here. The event library gives me a list of all of the events that are available to me. And you can see that we have a whole lot of them. In fact, in SQL 2012, we have about 700 events available to you, which is far more than you were ever able to get with SQL Trace. This gives you all of the events that you'd expect from SQL Trace, plus a whole lot more so that you can get very detailed information about everything that's happening. Now, in addition to the templates, which helps you identify which events you might want for a problem, there's other ways that you can find events. The best is you can just start typing right here in this search box. So you can see as I start typing statement, we actually narrow this list down to just the events that include statement in the name. Now, I can search for more than just name because you might not know the name of the event. You can actually search by the description, you can add the fields, or search by every possible piece of metadata that we have. So this just allows you to very quickly find things. You can also look at stuff by category. We can search and sort by category, which is very similar to the categories in SQL Trace. And then we have this thing called channel, which is used as part of our integration into event tracing for Windows. So we have these 4 channels available to you. And you can see here that by default I hide the debug channel, but you can select that and then see all of the events that exist in the system. The only reason we hide the debug channel is because that's something that typically is not going to give you information that's particularly useful to everyday DBA activities. That's more useful when you're working with our support group or directly with our development team troubleshooting a very complex problem. It gives us some information that's useful to us because we can look at the code. The next piece of the UI that's interesting is this configure button. We hit that and that slides me over to the place where I can actually configure my global fields, or what we call actions, the filter if we want to do that. So this filters at runtime, and it also just gives me another list of all of the fields that are part of this event, like in this case module start. I'm not going to go into a bunch of detail about what all of these mean. There's other information out on the internet about that. But this is just where you can configure stuff. And you can see I can actually configure every event individually. That's part of the extended event system, where every event can have its own actions, filters added. I can do them in group by control clicking. So if I select all those and make a change over here, it'll apply to all of them. Data storage, finally, is just where we can add what we call targets and extended events. This is just where you put your data. You can see here that we have a number available to you. I already have the event file defined, and that's all I want, and that's going to a place where I can take a look at it, and that's just collecting the information for me. So I'm just going to go click OK, and you can see now I have login demo created here. I'm going to say right-click, start the session, and now I'm actually collecting information about my login. So let's go back to my application, and I see again that I have at least one successful connection. So maybe the problem's gone away. That would be really nice if the problem went away just because we turned on extended events. But sadly, I don't think extended events is quite that powerful. It doesn't actually fix your problem just by turning it on. So we see that we have our failures again, and I'm going to go up and I'm going to grab my first failure. And I'm just going to grab this connection ID because that's what's interesting to me. I'm going to copy that, go up to the server. I'm going to stop the session because I've collected everything I want. And I'm going to pop open the session here and say event file, right-click, view target data. And you can see that's going to pull up, maybe. We have a filter there we need to get rid of. That's going to pull up the information that I've just collected. So this is everything I've collected about what happened during the login. And if I scroll over here, you can see I have this field called Client Connection ID. So that is what I pulled from the file where I ran my application. And I can just right-click here and say filter by this value, and I'm going to paste the value that I copied from my application window and click OK. And so what this has done, I'm going to resort by timestamp here, is this is showing me, you can see just the events that fired for that one connection over here. So that one that I gathered, all of these events have the same client connection ID. And now I can actually scroll over here and start looking at what happened during this. So I can see some wait info external happening. So that's a wait on an external thing, and we can see there's just some authorization going on here. So this is exactly what we said happens during login. I got that pre-login happening, then I went and tried to do some authentication, some authorization. I checked for the cryptops, still doing a whole bunch of waiting here. Did some security authentication, but then I see this. Now, if you've worked with logins during in SQL Server, you know that module start's not something you usually see. Module start in extended events means that a stored procedure is being run. And stored procedures are not necessarily what I expect to see. So I'm going to go look at the detail here. And I see that the object name of this module is connection limit trigger. This tells me something probably is going funky here. So I'm going to scroll a little bit farther. Expand over my statement. These are just fields available right inside these different events. And I can see some statements are starting. It's checking who the login is. But then it sets a max connection. That's interesting. Oh, and then we have something here. It looks like I have a little message. And I'm just going to pop this open in my view window. Maybe. I can see that my developer has left me a little love note here. He says, congratulations, you found a delay in server login. So you can all tell that my developer loves me because he has put a trigger into the system that stops me from logging in more than a couple times. So that wasn't very nice of him, and I can actually fix this problem. We'll call this fixing the problem by going into server objects, triggers, and I can see there's my connection limit trigger. And I'm going to disable it. But you can imagine in the real world, if this were your case and you were having some kind of timeout, obviously we've kind of faked a timeout here with this connection limit trigger. But if you were having a timeout by something, you could see where you could get in here and find, what was going on. Did we fail at authentication? Did we fail at cryptops? Was there some kind of wait happening? Or maybe you will find that there is a login trigger and it's doing something odd like, it's probably not doing wait for delay, but in this case, that's what mine is doing. It's just waiting long enough that it's going to time out my connection. And that wasn't very nice. And then you can go and fix that trigger. In our case, the fix, quote unquote, was to just disable it. And if I go and run my application again, what we should see is sure enough, all of my connections succeed because I no longer have a delay for my specific login, and I have once again beat my developer at his own game. So let's go back to the slides now that we've solved our login problem. The next thing we want to talk about is how do we use extended events and correlated tracing to solve complex query execution issues. To do this, we need to talk a little bit more about the idea of using activity ID for causality tracking. So in a nutshell, this is how we do this activity ID. A process, and in this case, a process can mean an actual executable, it can mean a thread in the server, it can mean a task in the server. These are all the notion of a process that we can track with extended events. So we have a process that is instrumented with extended events, and when it starts to run some type of work, it gets an ID. It gets this activity ID, as a matter of fact, and it starts firing the events. Now, each event in extended events has the capability of carrying what we call an activity ID, which you can see is represented by the A1.1, A1.2. So that's that idea we talked about earlier, that an activity ID is a tuple of a GUID and a sequence number. And here our GUID is just 1, because that's a little bit shorter and easier to put on the screen. Now, how we do correlation is we say, let's say we got to event 1.2 in process 1 and it needs work done somewhere else, like maybe this is a login that's being sent to the server, or maybe it's just 2 threads within SQL Server. Both of them work. But we send this request from process 1 over to process 2 to do some work. And process 2 starts up and it starts firing its own events. And you can see, first of all, that the activity ID A is 2.1. So this is a new thread ID, it's a new GUID, and that sequence number just saying that's the first event. But the difference here is that the parent ID, and in the extended event system we have kind of a funny name for parent ID. We call it activity ID XFR because it is the transferred activity ID. But it has actually recorded the activity ID of the event that called it. So the activity ID from process 1, 1.2, is the parent ID in process 2, the first action, 2.1. And then you can see each of these threads happily moves along, processing more events and giving them activity IDs, and each of them has the GUID is the same, but the sequence number increments. But you can see how in the second event in process 2, event 2.2, it doesn't have a parent because that specific event was not caused by the request. So it's this connection between event 1.2 and event 2.1 that creates this parent-child relationship, and that represents causality, where the event 1.2 we would claim caused event 2.1. And we can do this, like I said, within SQL Server from thread to thread or task to task. And with the new correlation in the client code that we're adding starting in SQL 2012, we can actually see this from client to server when we're running an RPC or a T-SQL batch. So now we're going to go ahead and take a look at how we do that. So first of all, we're just going to take a look at an application that I believe has some problems. And you can see here, this just runs a whole series of queries against my server, and it puts out the execution time. So it times them. As you can see, I have some things that are running a little bit longer than others. You know, some double digits, but some single digits, and I don't like that. I'd like to figure out what's going on. To me, this seems wrong. I wrote the app. The query shouldn't be taking this long, so something seems to be wrong in my system. Now, to troubleshoot this it's a little bit more complex. I'm not going to lie to you here. Where there's still some pieces that we need that need some manual work, but we do have links at the end of the presentation that will help you out with this. What we need to do is we need to set up something called bid tracing on the client. So if you haven't worked with this before, bid tracing is the tracing that happens at our protocol layer, whether it's ODBC or OLADB or even JDBC. You can actually do these bid traces here, and they will collect information into event tracing for Windows about what the client is doing. And this you need to enable if you want to track activity ID. So connection ID we looked at before, that's on all the time. Anytime you make a connection with this new TDS update, you will get the connection ID. But if you want to track queries using the activity ID, you do need to set up this bid tracing. Now that's more complex than I have time to go into as part of this demo, so I have a command script that does the hard work for me in terms of using Logman to set up the event tracing for Windows logs and start collecting the information and registering everything. And I'm just going to go ahead and start that. We'll try that one more time. And as you can see, that just called Logman and set up some specific traces, and now it's waiting for the repro to happen. I'm going to go into my server very quickly here and get another session. Here you can see our wizard. I'm going to set up my query demo, and again I've used a template, so I go into my query perf template. The wizard is very much like what we call the advanced UI. You'll see we have the same event library. The only real difference between the wizard and the property dialog version is that the wizard does everything in aggregate. So I can choose a whole series of events, but anything I pick here in the action list, the global field list, will apply to all events. I'm not going to change anything. If I change the filter, it would apply to all events. So essentially, you can't configure individual events in the wizard. And you can only use the file, which I've already set up, or what we call a ring buffer. So essentially, the wizard limits your options a little bit, but the goal is to allow you to very quickly set up sessions that you already know you want. You don't want to go into a lot of detail. So I went ahead and I created that, and I can see query demo, so I'm going to start it. So now what I'm doing is I'm collecting information about query execution on my server. Here I'm collecting information about query information I'm sending from the client, and I'm going to go ahead and run my demo again. So it goes and runs some stuff, and you can see I have even more problems here with even longer execution time, so that's actually good. I'm going to go over here and press any key to continue, and it's actually going and stopping the trace on the client, and it's using something that we call log parser to parse through the ETW log and do all of the work of digging through it and finding the information. You can see that it's actually given me a summary here of a number of threads that it considers to have taken a long time. So I've run my demo. I'm going to go ahead and stop the session just so it doesn't collect more information than I need. And I want to go and look at, make sure I get the right thing here. Yeah, slow request text. Slow request text is just the file that log parser output to show me that these are all of the specific events that fired for different threads. So these are all of the slow threads. Any thread where I had a longer duration, we parsed those out, put it into a text file for convenience in my purpose. And again, you can figure out how to do this using the information out on the internet about log parser. And what I'm really interested in here is if I scroll over, we'll just use this first thread since they're all just as good. I'm going to scroll over and I can see all these different events. And I can see where I'm execing something and I'm setting up an API and sending out a command. If I scroll over far enough, I can see this activity ID has actually been collected. So this is the activity ID we talked about that gets generated when you do RPC or batches. So I'm going to copy that. And we all want to remember that 6 was the sequence ID here. So I'm going to pop into this session that I collected here on the server. So this is all of the information that we collected about query execution. I'm going to say go ahead and view that target data. Get rid of any filters that I have. Now you might remember I said that there's these activity IDs. You can see that I have the activity ID and I have parent activity IDs, the activity ID exfer. Now I have pulled that up already into my table view, and just like we showed in the diagram, in the animation, when activity transfers, when I send a request, say from my client to my server to run a query, the ID from the parent, the client in this case, gets recorded in the attach activity ID exfer. So my first job is going to be to filter by that. So I just do right-click filter. I'm going to paste that activity ID that I copied out of my client trace because that's the parent I'm interested in. And so this is a little bit bigger file, so it takes a few moments to go through the file and filter by that activity ID exfer, my parent activity ID. So now I'm actually seeing all of the events that came from that parent. Now, like I said, we're only interested in this specific one, number 6. So I'm going to look down here and see if I got it. And now it doesn't look like I got it. So what does that mean? This is actually an interesting thing, and it was on purpose. So extended events has this notion that what we call our prime directive is that the most important workload on the server is in fact yours, not ours. And what that means is that we'll drop events. By default, extended events is designed that if we get a lot of events, if we're on a high volume server and we get to a point for some reason we would have to block the server to write an event to our file, we'll throw that event away. Now this is configurable, so you can change the configuration of your session and say, I don't want to drop any events, but that leads to a potential that you could start blocking the server for your trace output, which is usually not what you want to do. So we make the default availability to drop events, and we can see what happened here is I was just taking a lot of stuff. There were a lot of queries running through this server, and this was running on my little laptop. And so the event session just had too much information. So I'm going to go ahead and look at this next one here, which was 48. This is another thread that had a slow response, and let's see if 48 is there. And 48 is there. Okay, so that one we did capture. So that first thread, we dropped that parent ID, that we dropped that parent event. And you know, that's okay, because when you're collecting thousands or hundreds of thousands or millions of events, dropping an event here or there is actually preferable to slowing down your own workload. But we were able to see the second thread, 48, that's there. So the next thing that I want to do is I actually want to go and see where this thread started. This was the thread ID in the server, our activity ID on the server. So I'm going to go ahead and copy the cell. In fact, I don't even need to do that. I can just say filter by this value. So I can see filter by the attach activity. I don't want the parent ID anymore, because what this is now telling me is I want to filter my entire set of events to just look at what happened in this one thread. So we ran a query on the client. It sent the record up and said, hey server, run this query. Here's my ID. That was my parent ID along with the sequence number. I used that to find all of the requests on the server that came from that client. And now I'm transferring over to the activity ID on the server so that I can see what's happening on the server for this one instance of this query. And so that's going to filter. Again, it's going to take just a few moments while we go through and let it filter through all of the events and find just these activity IDs. Once that finishes, now I have the complete record of what's going on for this one thread. And I'm going to see, I have a whole bunch of page latches. So I can see, first of all, here's my select statement, and I have all these page latches. And what I'm really interested in here is this duration field. I'm going to kind of scan down the system and look for something with a long duration. But you know, I can see all these page latches. Oh, that was kind of long. Let's see if we can find anything else. You see a lot of work was done here. Because it's interesting to see what's going on. It looks like maybe that one up on top was our longest one. So let's go back up and look at that. We can see, okay, you know, 4,310 milliseconds is pretty long. It's interesting to see what happened right before that. And, you know, this is my whole series of page latches. So that's interesting to me. And, you know, there's a whole bunch of them. The duration is not very long, you can see, but that many page latches means that we have some kind of a latch going on. And so we're going to take a look at that statement. And we can see here, you're probably already getting the idea of what's happening. If I can scroll down in the details here, I can pull this up and I can see that this is a select star into pound prod. So I'm actually selecting information into a temp table. Now, if you've done any work in SQL Server, you probably realize that working with temp tables can cause some issues. Maybe my temp DB is on a slow disk, and in fact, that since this is all running on my laptop, we can pretty much guarantee that my temp DB is on a slow disk. So when you see this type of query where I'm selecting a bunch of information into temp and I see a whole bunch of page latches, you have a pretty good idea that I'm having temp DB contention, and this would be a really good indicator about, you know, taking that query. I can say, whoa, look at that temp DB contention. Now, if you're not convinced yet, you could actually even take this session to the next level, and we're not going to go through all that, but we will take a quick look at what that next level would look like. I can just go ahead and right-click on that query demo, go back to events. I'm just going to type in latch, and you can see that latch suspend end is one of our events. And I could actually add this latch suspend end, because I saw page latch, that's interesting, latch, page latch, latch suspend end, and if I go down and look at the events, which I can see here, I can see the description. This occurs whenever we return after waiting for a latch, so we saw that latch wait. This would probably fire after that. I can see that the fields I would have returned is the file ID, the database ID, and if I scroll down a little bit, even the page ID. And I assure you that if I would complete this to the next logical step, if I really wanted to be absolutely certain, I could go and add latch suspend end into my session. I could go rerun my repro while I'm collecting this, and what I would see is a whole bunch of latch suspend end events occurring on database 2 because all of those latches are actually happening in TempDB. But I think everybody who's worked with extended or worked with SQL Server long enough knows select star into a temp table with a bunch of latches before it. That's TempDB contention. We don't have to prove it any further than that. So that's all the demo. So we're going to bring it home here and kind of go back over what we were talking about. We saw how we were working in always on. We saw some login problem that we were able to identify and fix. And then we went into troubleshooting query execution down to a very detailed level of what happened and figured out what we could do to solve that problem. That brings us to, so what does all this mean? Did we really get something out of this? And what I hope you got out of this is these 3 key points here. Is like, first of all, is the efficiency of extended events. You're able to, you can see how, especially in that login, and even in all of these demos, you can see how extended events is enabling you as a DBA to just get right to the root of the problem very efficiently. At the end of the day, your job is to fix the problems, not spend a whole bunch of time finding the problems. And we think that extended events is going to make you much more efficient at that, whether it's in always on, where you can use the default logging to very quickly identify the problem, all the way to these very complex query problems, where you can very quickly, through the use of correlation from your client, say like, oh, this is the problem where the client saw the delay. I can drill right into which query and which thread caused the problem and see very quickly what was happening on that thread, or identifying the logins with the connection ID. The second piece of information is how you can get this deep insight using extended events. We have almost 700 events, I told you, that gives you this very detailed information about what's going on within the database engine. Back in the days of SQL Trace, you could get, some high-level information, some medium-level information like locking and things like that. But now with extended events, you can drill all the way down to, we can see exactly what waits are happening on the system on a per query execution basis. You can go in and look at things like latch, suspend, end, these very detailed events, what I like to call very close to the metal. We have a lot of events that are really tied to the implementation of the product itself, so you can see exactly what's happening and exactly where our problem is occurring, and that will help you identify what it is that you need to fix. So that gives you that deep insight into the problem that you need in order to fix it quickly. And then finally, throughout the demonstrations, we were able to look at the new SQL Server 2012 extended events UI that we built right into Management Studio. This is going to make the system much more usable for you. If you worked with extended events at all in SQL Server 2008, there was no UI. You had to use DDL to create and manage the sessions, and you had to use XPath queries to read the results. And we have now replaced that with our user interface. And it's not only can you use it to do stuff quickly if you're an advanced DBA, we think that this is available for DBAs at all skill levels. Now, I do want to assure everybody that if you just really love our DDL and our XPath queries, you are welcome to continue using them. We have not disabled them or anything. So those are there for those that want them. But for everybody else, we definitely hope you check out the Management Studio UI. It certainly makes working with extended events a lot easier and a lot quicker. As I promised, here's some of the links that are available, particularly if you're interested in trying out some of this correlated tracing between the server and the client. You're going to want to look at the setting up the data access trace and SQL Server 2012 data access trace links, as those will go into more detail about how to do tracing at the client using that bid system. Down at the bottom is our team blog, so you'll find a lot of good detailed information there. And so with that, I wish you a good morning, afternoon, or evening, wherever you are, and hope you enjoyed this talk about extended events and using it for troubleshooting and tracing in SQL Server 2012.